Today we're going to be finding the distance using Pythagorean theorem. So the date that we're going to put on the side is 11/14/19. Our first example is asking us to find the length of each line segment shown below. So to do that, I'm going to first make our line segment a little bit more clear for us to see, because it's a little too dark on our note sheets that it might be hard for us to recognize where they're asking us to find the length. So whenever we try to find these lengths, what we do is we count the squares inside of our 2 points. So I have 1 square, 2 squares, 3, 4, 5, 6, and 7. We don't count the lines, we count the squares. So this has a length of 7. The example to the right, I'm going to do the same thing, make it a little bit more noticeable, and then I'm going to count the squares. So I have 1, 2, 3, 4, 5, 6, 7, 8. So my length for this line segment is 8. Continuing on, we're going to fill in our 3 steps on how to use Pythagorean theorem to find distance on a graph. So my first step is I want to draw a right triangle. Making the line between the 2 points the hypotenuse. Between the 2 points, the hypotenuse. My second step is I want to count the squares on the legs. And my last step is I'm going to use the Pythagorean theorem to find the distance. So to put that into practice, we have our 2 examples below. So it's asking us to find the length of each line segment shown. So again, I'm just going to darken the line segment that they give us. Notice how this one is diagonal and the examples above were straight. So I can't count the squares for this one. That's why we have to make our right triangle. So to do that, I can just make a right triangle right here. And then we have now completed our first step. So our second step is I want to count the squares on the legs. So my legs are shown in red. So the boxes that are in between that point and this point down here is 1, 2, 3, 4, 5, 6. So this side would be 6. Looking at this point and this point, I have 1, 2, 3, 4, 5, 6 squares right here. So my third step is I want to use the Pythagorean theorem to find the distance of this blue line right here, or our hypotenuse. So plugging that into a squared plus b squared is equal to c squared. I have my a, my b, and my c. I know that a is 6, and I know that b is also 6, but I don't know what c is, so I'll just keep it as c squared, or you could put an x there. Now I'll have to solve on the left side. 6 squared gets me 36, plus 36 again. is still equal to c squared. Whenever I continue to solve this, 36 plus 36 gets me 72 is equal to c squared. To undo a square, I have to square root both sides, and I would be left with c is about 8.5 when we round to the nearest tenth. So my side length for right here would be 8.5. Doing one more example, I will darken our line a little bit more. So they're asking us to keep this as our hypotenuse and draw a right triangle. So to do that, I'm going to draw my legs. And I have my right triangle right here. So the value of this leg right here is 1, 2, 3. And this leg on the bottom is 1, 2, 3, 4, 5, 6, 7, 8. So to find C, I'll have to plug in my values for A and B. I'll make this one A this time and this one B. And this is still C over here. So plugging in 8 as A, I'll have 8 squared plus B is 3, so 3 squared is equal to C squared. 8 squared gets me 64. 3 squared leaves me with 9, and I still don't know what C squared is. So 64 plus 9 gets me 73 is equal to C squared. To undo a square, I'll square root both sides, and that will leave me with C equaling about 8.5 again. So this side length we said was 8.5. Now moving to our back side, what is the distance between C and D, it's asking us. So the distance between C and D, I'm going to first connect my 2 points. So just like that. Then I want to draw my legs so that I form a right triangle. My next step was to count the legs. So looking at this side right here, I have 1, 2, 3, 4, 5 squares in between. And looking at this bottom leg, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then plugging in what we know into our formula. A I will make as 5, B as 12. So plugging those in, I'll have 5 squared plus 12 squared is equal to C squared, which we do not know. 5 squared leaves me with 25. 12 squared, 144. Still don't know what C squared is. 25 plus 144 is 169 is equal to C squared. To undo a square, square root both sides, and that would leave us with 13 is equal to C. So 13 is our distance between C and D. Our last example says a conveyor belt needs to be built outside of a factory to get materials inside of the factory. If the end of the conveyor belt is 60 feet away from the building and the conveyor belt has to reach an opening 11 feet high, what does the length of the conveyor belt need to be? Draw a diagram that supports your answer. So drawing a picture will be very helpful in this. So I'm going to first start off by drawing my factory, which is just going to be something that looks like this. Nothing too fancy. And then it says if the end of the conveyor belt is 60 feet away from the building. So my building starts right here, and if I go 60 feet away, say that that is 60 feet. And the conveyor belt has to reach an opening 11 feet high. So I'll say that my 11 feet high is about like right there. So I know that this side right here is 11. So as I can see, this formed a right angle. So that means that I have my hypotenuse connecting those two things. It didn't go all the way out to the 60, but that's my fault. Maybe that will help. Okay, so now we have our conveyor belt drawn, and we want to find the length of the conveyor belt. So to do that, we can still use our Pythagorean theorem because we have a right triangle drawn. So plugging in our values, I'll make A 11, and I'll make B 60, and we still don't know what the length of our conveyor belt is. So whenever I do 11 squared, I'm left with 121. 60 times 60, 6 times 6 is 36, and I'd have 2 zeros. And this is equal to C squared. 121 plus 3,600 leaves me with 3,721 is equal to C squared. To undo a square, I will square root both sides, and I'll be left with C is equal to 61. So to answer this question of what does the length of the conveyor belt need to be, the conveyor belt, since this is a word problem, let's make sure that we answer in words. So the conveyor belt needs to be 61